this computer, and then I'm going to hide the video panel. Okay, great. Okay, good day, everyone. Welcome to the Toronto Community Twitter Developers and Data Enthusiasts October 19th, 2021 event. First of all, sorry about all the disruptions. We had some unexpected occurrences happen, but we seem to have it under control. Except, Steen, if I think there's still someone here, if you don't mind kicking them out,
Yeah, sure.
that would be great. Okay, awesome. So today's event is hosted by myself and Steen Montero. A bit about me. I live in Greater Toronto area. I consider myself to be a professional miner. I used to mine for oil in Alberta as a chemical engineer, but now I mine data. Commodity is the new commodity is very important, and oil used to be a very hot commodity, but it seems to be on its way out. Data is the new commodity, so I am now in data. The other organizer for today is Steen Montero. Steen, I will pass this on to you for a brief introduction.
Hi, I'm Stein Montero. I'm a research fellow at the Canada Excellence Research Chair in Migration and Integration at Ryerson University in Toronto. I do research in migration and integration issues, specifically migrants living in Canada. I also analyze the conversations that are happening in Twitter using the Twitter API, and I study the diaspora living in Canada and how they connected to various to other diasporas in other parts of the world as well. So yeah, I'm excited to hear the conversation on the extreme weather. Yeah, Yasser.
Thank you, Steen. Thank you for that. So the agenda for today is as follows. We will start by highlighting our community and why we exist and what we're offering. We will then move on to our main session, which is a conversation around extreme weather, which is presented by our much esteemed special guests, Jim Moffitt and Naheen Mahani. This talk will then be followed by a networking session, which will be about 20 minutes long. Shortly after that, we will conclude the event. So the Twitter community for developers and data enthusiasts is a place for those who are interested in working with the Twitter's developer products and APIs. We are a global community with clubs in many cities, and we bring developers and data enthusiasts together to share best practices and learn more about the Twitter platform. We enable developers of all levels to connect with people with similar interests in technology and to learn new skills. We will be organizing coffee talks, workshops, and hackathons. Our goal is to help support local developer communities as they grow. Moving on to our main session, I would now like to introduce and welcome our featured speakers and special guests, Naheen Mehtani and Jim Moffitt. Naheen is the director of Yayasan Pita Benkana, also known as the Disaster Map Foundation. Yayasan is a Southeast Asian-based NGO committed to enabling more equitable forms of climate adaptation. They develop software infrastructures for community-led disaster co-management. Naheen, our guest, is a humanitarian designer, architect, theorist, activist, and artist. And just this year, she was recognized by Forbes Asia 30 Under 30 for her contributions to the region's social issues. Jim Moffitt is a senior staff engineer and partner at Twitter. He's an expert on developing early warning systems. He writes long-form articles on the Twitter developer forums and is active on GitHub and Twitter, where he has amassed over 1,000 followers. I welcome both of you. Jim, I will now unshare the screen and pass this over to you. Okay, over to you, Jim. I will unmute Jim. Okay.
All right, now you can hear me.
We can hear you, absolutely.
Awesome. And everybody can see the screen.
Yes.
Yeah, hi everybody. My name is Jim Moffitt. I'm on the developer relations team here at Twitter. And before working with the Twitter API and Twitter data, I had a software development career in developing flood warning systems. So I'm very excited for this session tonight, and it's definitely my favorite Twitter use case. So before we get started with the content, I wanted to share, we at Twitter just recently, we released what we call a extreme weather campaign, where we highlight data visualizations around 4 different stories, including the Peta system, which we'll be talking about tonight. And this campaign includes 4 visualizations, and I highly encourage you. Here on my screen, you can see a link to where this is hosted. But these visualizations are really creative ways to share the story behind 4 different extreme weather events. The one I'm showing here is the Jakarta flooding topic, which we'll be digging into tonight, but also we have stories about the Texas freeze that happened over the winter, and also bushfires in Australia and the effects that effects there, and also a typhoon in Japan. And all these visualizations kind of relay how the story unfolded on Twitter, and how the types of conversations that just happen organically on the Twitter network during these events. So highly recommend that you check these out. I'm going to go to my next slide. And to introduce this topic, I want to talk about some core Twitter characteristics that make Twitter such a compelling communication channel for early warning systems and for public communications during extreme weather. The first is that Twitter is an open social media network, and thus a public broadcast channel. The public nature of Twitter is a fundamental reason it is a go-to channel for these floods and other natural disasters. And also, Twitter also supports private messages, which during emergencies can be used for notifications and for the exchange of private information like phone numbers and addresses. Also, Twitter is real-time. It's probably one of the most real-time networks out there. Towards the end of this presentation, we'll demonstrate the real-time performance of the Twitter network. And then another core characteristic of Twitter that makes it just a natural component of these types of early warning systems is that it's mobile focused. And during emergencies, it's key to have to enable the public to use their phones while they're out and about and share observations or get information about where they are. And here's some more little deeper reasons why the core characteristics of Twitter make it such a match for flood warning system. One, of course, Twitter is all about short content. It's concise messages. These messages work well with lower bandwidth networks. Another is that Twitter essentially was built to share information, and information like photos and videos, web links, app installs, in our case, weather and river data. And early warning systems are built to provide alarms and notifications, and Twitter supports many types of notifications, and these can really help extend the reach of early warning systems. So before we jump into the details of the Peta system, I want to just give a visual tour of some examples of Twitter integrations or integrations that are using Twitter data within the domain of extreme weather. And what I'm showing here is a tool that we actually built in-house to demonstrate this. And what this is a collection of tweets around Hurricane Harvey back in 2017, which really flooded many areas, especially Houston and other areas along the Gulf. And what we did here is we collected all tweets that we could geo-reference to the Houston area or Texas area during this hurricane. And we used it to explore what different types of conversations happen on Twitter during hurricanes. And the major themes we found were, of course, people and agencies sharing weather and storm information with the public. Another huge theme, of course, was people sharing photos and videos of the damage as it was occurring and also afterwards. Another theme that was very prevalent was what we call SOS messages, people trying to organize rescues. And that, again, this is where some private messaging can come in handy, where you can share information about where people are. But that was certainly a theme, because during this hurricane, for example, a lot of cell networks went down. AT&T, I believe, went down. So social media networks just became a natural place for people to share that type of information. And two other themes we found were people, not only human rescues, but animal rescues and agricultural rescues of livestock, et cetera. And then the final major theme was recovery and people, and helping organize people for volunteering or for donations. And a lot of people naturally coming into Twitter and other networks, just seeing how they could help. Here's another visual for a system also from Texas, actually. There was a group at the Water Science Center in Austin, Texas, and they've built a system that integrates Twitter to share river and rainfall data coming in from well over 700 different sites around the state. So they receive this data at their facility, and then they automate the tweeting out of these data points only when they're in flood stage. So they work with the National Weather Service. And if any of these gauges is within a flood stage and because of rain or because of their models, predicting that floods are about to happen, they send out these automated tweets, and therefore they're shared publicly. Other agencies and other researchers, even TV media stations can hook up to listen to these tweets coming out and get real-time on-the-ground data from river gauges and from rain gauges. So here's our first introduction to the Pettit-Bachana system. And what this is it's a map of the outline you see there is the boundary of the city of Jakarta. And this is all data from the first full year that they deployed this system. And those blue dots show where individual geotag tweets were coming from during the first year. So these are all geotag tweets that were sharing flood observations. And as you can see, even in the first year, this system was very successful in crowdsourcing observations. And now I'll pass the baton on to Nasheen, who can talk about what they built and how it works. So I think you'll have to unmute her.
Okay, thank you, Jim. And thank you also to Yasser and Stein for organizing the event and to everyone joining us today. So yeah, as Jim mentioned, I just wanted to share a little bit about what the Twitter API has enabled us to do with real-time disaster mapping in Indonesia for response and recovery. And as Jim shared in this image, there is an incredible wealth of information that can be leveraged from people tweeting about flooding. This is what our team saw, and as a result of this, built out the system I'm going to share. So just to give a brief introduction, our work started in Jakarta. This is what the city looks like from the coastal edge. It's a city of 31 million people, so just a bit larger than Toronto. And it's on the coastal edge of the world's most disaster-prone region. So of course, flooding is very frequent in this area. And in fact, it's an annual occurrence. But the way flooding is happening is, of course, changing. And I share these two images here because both of them are images of the central business district, which historically were never flooded before. But here in both these years, and even in the years in between, we see very often that they become completely inundated. And the reasons for both of these events was an infrastructure failure. A portion of a canal wall broke, resulting in a sudden and unexpected failure in areas that typically weren't used to experience flooding. And what's important to point out about that is that no matter how much predictive modeling we have, nothing could have anticipated these events. Nothing could have predicted that the pressure points would have been in these locations, that the walls would have bursted at these locations, causing these neighborhoods to flood. And what we're experiencing with climate change is a greater intensity of weather. And so we have more water falling in a shorter amount of time. And the infrastructures we have in our cities aren't designed to handle that. And they can't keep up with the increasing intensity of the climate. And so they're bursting and breaking under increasing pressure, causing these sudden and unexpected failures, which cause disasters that are far greater than just from the weather alone. It's when the weather meets our cities, that's when the disaster happens. And most of the major flood disasters in recent years in Indonesia, as you can see in these images, were a result of these types of infrastructure failures. And the reason I begin with this is to point out that what we really need now, in a time when we can't predict the weather in the same way that we could before, is real-time information, so that even though we cannot anticipate these events, when they do happen, people have the location-based information they need to make time-critical decisions about safety and response. We know that information is the most important resource in a disaster, but often the challenge is how do we collect this information in real time? And although cities like Jakarta are often thought to be data scarce, that perhaps comes from this idea that there isn't a lot of formal data. But as Jim showed in that initial map, there's actually a lot of data there. It just exists in different forms. And in fact, this region, the ASEAN region, is home to 100 million more smartphones than people, and has some of the highest social media usage rates in the world. And even during the flood, even when standing knee-high in floodwaters, people are actively sharing information with each other. What this represents is a tremendously rich and precise data source, because all of these devices that people are carrying around with them in their pockets are connected to a GPS system and social media networks, which allows for the ability to precisely share location and details of context-specific conditions. And so the question then is, how do we make use of this heightened use of social media during emergencies? How can we take advantage of all of this data that's being shared and filter and structure it quickly so that it can help recovery efforts? And so our team developed an open source software called Cognicity to address this. And how it works is that by connecting to Twitter's API, we are able to listen for specific keywords in social media posts. For example, flood or earthquake or fire. And as you see in this image here, if someone is tweeting about flood, if their post contains that keyword, we are able to catch that. And then we have a bot that sends an automatic reply immediately within seconds to that user, introducing the project, introducing itself as DisasterBot, and asking users if they would like to submit a flood report or a disaster report. And if the user responds, they're guided through a few steps to submit a report, which includes confirming their location, adding a bit of details about the disaster, such as the flood height, add photos and description. And as soon as they submit, in less than 0.01 seconds, that appears on a real-time map, which is designed to be a mobile-centric website accessible through any browser, and especially in cities like like many of the cities in Indonesia that don't have very good internet connection, this is designed to load extremely quickly and on the most basic mobile phones. So these are some of the examples, for example, of the reports that people are sharing about, blocked roads, about broken infrastructure, about fallen telephone lines causing blackouts. And it's a method of crowdsourcing that allows us to reach millions of users, allows us to pull information from street level, from the people who know the situation best in real time. And at the same time, we are working with the government agencies who are now monitoring the map in their control rooms to attend to resident needs. They say that it has significantly reduced loss and increased the speed of response times because they're able to much more immediately and more effectively allocate rescue and resource efforts to the places in need of it in real time. And importantly for us, what this enables everyone to do is more equally participate in decision-making and resource management in their communities. We say that it is democratized decision support tools because instead of concentrating decision-making in a small handful of people just sitting in a control room, this way every resident in the city is able to participate in this process. We see that the penetration of mobile phones and the usage of social media in the region especially has significantly lowered the barrier to entry to participate in civic management. You don't have to be an authorized official to submit a report or to make a decision. Any resident is considered an expert of their area, and by having access to the same information through their mobile phones, they can take immediate action, which both empowers people during emergency events to coordinate their own response efforts. But as a result, with everyone in the city participating in this way, it reduces the burden on central agencies that can only do so much. And as a result, reduces loss for the city as a whole. And so what started as a real-time flood map in Jakarta in 2014 has now expanded to a multi-hazard map for all of Indonesia. So not only for floods, but we're listening for other keywords now through the Twitter API, including earthquake, forest fire, haze, extreme wind, volcano, and we've designed a system to enable reporting for these hazards. And by the end of this year, we will be on a national scale in the Philippines as well. And I just want to close by saying that as we've seen this year, not only in Indonesia, but throughout the world, the weather is going to get more extreme. And it's really important to involve all residents in their own disaster recovery efforts and think about emergency governance differently. And in our work, connecting to Twitter's API has allowed the platform to support real-time coordination at an unprecedented scale. We just had a meeting with one of the government agencies who said that this is the fastest source of verified information, much faster than any ministry is able to provide during emergencies. And it's really, Twitter's API is such a great tool to harness this already active participation that's happening on social media and use it for the types of civic engagement and cooperation that will be essential to addressing the challenges that we're facing today and into the future. And so I'll close with that and pass it back over to Jim.
Okay, so now you can hear me again. Thank you, Nasheen, for that awesome presentation. I can say that we here at Twitter, we're thankful that you pioneered this type of crowdsourced disaster communication system. And we're proud that the Twitter network could play a role in what you built. So let's go to the next slide. I want to talk a little bit about the pieces of the Twitter API that is used to drive this system. One thing that's core to the system is listening for tweets of interest. And Petibachana is using our real-time streaming endpoints for this. So what that enables you to do is to set up a query. In fact, if you can see my slide here at the bottom in green, I have an example query of the type of query you can put into the system. And what it does is in real time, it's actually checking every tweet in the fire hose. So, you know, thousands of tweets per second. And if any one of those matches your filter, it sends it to you in a real-time stream. So they're enabled to receive these tweets of interest within seconds of them being posted. So, and we'll show a little demo of this in just a few seconds. The other part of the system where they're using the Twitter API is, of course, in automating these tweets that go out to users. If you make a flood report, the system automatically sends a query back to that user saying, hey, I'm the disaster bot. Can you please follow this link and put in your information? And that information includes, you know, if there's a map where you can drop a pin exactly where you are. That map is created with that phone's GPS, so it already sort of knows where you are, but you can fine tune it. It also encourages you to upload media such as photos. You know, listening for tweets is key to the system, but also posting tweets. So now I want to do a quick real-time demo. What I'm going to do here, can you all see my blue terminal that I pulled in? Great. So what I'm doing here is I'm starting a real-time stream. I need to authenticate in, so let me try that. Make sure I typed it right. I did. Yay. So the first part of the demo is succeeding. What I'm doing here is listening for tweets that have the hashtag Twitter dev demos. And I have here on my phone, I have a tweet that I'm going to hit send with. And you're going to see this tweet object show up on my terminal. I'm going to hit the tweet button right now. Boom, and there it is. So that's really, illustrates the real-time nature of the Twitter network. I hit the button on my phone. If you think about where that tweet traveled, across my cell phone network to a data center, into the Firehose system, into the system that's looking for tweets with that hashtag I set a rule for, and boom, it comes back to my computer. And this all happened within seconds. So it's really an amazing real-time system. When I was in the flood warning world, we thought a lot about latency. And when you're having a flood situation, often the data that's getting pushed around to different agencies, it's a polling system. And every time there's a hop, it can take a few extra seconds. So it might take a minute to get the data you really need. But when I first learned how quick this Twitter network was, I was really amazed. And that's what got my thoughts going about how this could be a really fundamental communication channel for events like this. So with that, with the demo being successful, any questions yeah, Yasser, I'll pass it back to you. Sure.
No, thank you, Jim. Thank you, Nasheen. This system, it's so important, so helpful, and so interactive. It's incredible. I'll start off the questions, and any Jim or Nasheen, either one of you can answer this question. I wanted to ask about the maps that are already that are actually, like when we're working with the app, we actually see maps, we see pinpoints. So these maps, like where are these maps coming from? Are they from Cognicity, or are they from Twitter, Google Maps? Who is behind those maps? Okay, and I'll just unmute. Sorry, I'll unmute Jim, and I'll unmute Nasheen as well.
Awesome.
Okay, great. Okay, they're both unmuted. Yes.
So for the maps that are powering the Pata Bencana system, just to say again, all our software is open source, and all our data is open data as well. And so the map that's underpinning the platform, we use humanitarian OpenStreetMaps. And we get that, that's our base map that we're using. And then we also have a filter through Mapbox.
I see. I see. And these maps that are open source, are they like worldwide or are they only for like Southeast Asia?
So right now, the platform is active in Indonesia and the Philippines, but the software is designed to be translatable across geographies, across hazards, across language, so can be adapted for other uses and has been already adapted by groups in Vietnam, in Hong Kong, and currently now in India, there's a pilot as well to develop their own real-time maps for disasters, and in other cases for like food waste distribution as well.
I see. Okay. No, that's good to know. That's good
I
to
was
know.
I was going to add too, like Nasheen mentioned, this example is written with OpenStreetMap as well, and also there's another source that I've used before called Leaflet. It's another lightweight mapping system you can plug into your website. It has all types of tiling support, and then of course to do the mapping of these pins or these icons. With our querying language, you can set up a rule saying, I only want tweets that have a geolocation associated with that tweet. And then, so when you start collecting those tweets inside the JSON, of course, there's a lat long representation of where you should put that tweet or that icon or that pin. So just wanted to touch upon that.
No, that's good to know. And this GPS coordination that is already attached to everybody's tweet. So like Twitter is already, I guess like if I'm tweeting something in the API, it is captured where exactly I'm tweeting from. And is that what the software is using?
No, well, users they have the option to share location, but by default that's turned off.
Okay.
So I'd say a normal tweet won't have the location of where the person was when they tweeted, but it's important, and that's another topic around this flood warning world, is if you're going to build a system and say you're building a system that's going to map things, it's really important to teach the public or your audience to know that they need to geotag. When you compose your tweet, you can hit the pin and you can select a location. So it's really kind of a key part of these systems. If you're going to rely upon their location, you really need to teach the public on how to do that and why they should do that.
I see. No, that's good to know. That's good to know. And so if somebody's tweeting, let's say if somebody tweets with the word flood in it, at what point, like, how does the system know that this tweet is legitimate and it's with regards to a flood happening in an area, and the user, he's not just tweeting about something else. So how do you like verify that, or if I tweet let's say anything with the word flood, like am I going to see a bot approach me every time, or how does that work out?
Yeah, I think this was very important for us. So there's a reason that the software was developed, and it's not just passively data mining all of the tweets with flood and mapping that. Instead, the bot asks the user to confirm, because in Indonesia, the word flood is used for many other things, like there's a flood of tears or like a flood of sail or something like that. And so in order to make sure that we're not plotting those on the emergency map, that's why the bot is so important, because it sends the message to the user and asks them, are you really in a flood? Would you like to submit a report? And only if the user goes through that step of saying like, yes, I would like to submit a report, and then they add in the details of the flood, only that is put on the map. The original tweet that they sent is used as a first filter for the bot to reach out to them, and then they're asked to participate. When they voluntarily participate, that is what we plot on the map.
I see. No, that's good to know.
And there's other strategies as well. Some systems, another piece of geographic metadata that is part of this system is every Twitter account, you have the option to set up your home location. You can say, I'm in Boulder, Colorado, I'm in Jakarta. And that's another technique, is when that person tweets, their public home location is shared, just like every other public aspect of their profile. And then you can filter on things like that. You can say, hey, if somebody's mentioning flood and they call Indonesia home or Jakarta home, that's another technique to only pull in the tweets that you truly care about.
Okay, no, very
Yeah,
interesting.
so for example, Yasser, you mentioned that if you tweet flood, you won't get a response from our bot because we're just programmed to listen to like the ones coming in from Indonesia and the Philippines at the moment. But of course, like as Jim mentioned, this is customized. Also, like initially we started just by listening to Jakarta, and then we expanded to Indonesia, and then now to Indonesia and the Philippines.
No, that's good to know. Thank you, Nasheen and Jim. I don't mean to hog the Zoom meeting here, but just one more question, and then I will pass this on to Steen and other guests. And for the system to work, we have the end user who is inputting the data, basically informing everyone about the flood happening. Who else is involved in this process? Are there other parties that are also involved in this, or is it just the user and the user tweets, the bot kind of verifies this, and then it goes online, or there's like other parties as well that are involved?
Yeah, so as soon as the user submits the report, that is put on the live map in real time. It's publicly accessible. But we are, of course, working with many different stakeholders in order for this to be used during emergency response. So we partner with a lot of first responders, NGOs, and the government emergency management agency, both at national level and provincial levels, who all are monitoring the map. They're adding in their own information when they need to. So like official government information, official information from the NGO. And in order to both understand what type of reports people are submitting, and in some cases also verify that. So like if they see a report coming in from a certain neighborhood, that's immediately on the live map, but they might call their ground staff to double check and say that, is there something really going on there? This is what we've received, and like start to plan the resource allocation in that way as well.
Okay, no, that's good to know. That's great to know. Thank you, Nasheen. Are there any other questions?
Can I ask a few questions?
Yes.
Yeah, so yeah, this presentation was super interesting. I really like the application. So my question is more on the endpoint itself. Is this something that's available to anyone, or is it restricted in a certain way?
Yeah, I can talk about that. In fact, I have a slide that I'll advance to that kind of shows some of this information. As you may know, we're in the middle of launching what we're calling version 2 of our Twitter API. So, as you may know, Twitter, the API is made up of, say 30 different endpoints. And one of those endpoints is a streaming-based endpoint that we've been talking about tonight. And as part of V2, we have a version for that. It's called Filtered Stream. And it's publicly available. Now at Twitter, when you set up and want to apply basically to use these free endpoints, you have to get an approved developer account. And basically that's just a process. We want to better understand how you're using the data. If you're a hobbyist, we want to know if, are you building something that's going to be commercialized or not? Are you a student? Whatever your story is, you go through this quick process. And in fact, we're going to make an announcement in a few weeks where we're going to pretty much provide instant access to anyone. But once you get that access, you can go to our developer.twitter.com website. You can read about these endpoints. There's get started guides for all of them. But that gives you free access. And with the starter package, if you want to call it that, you can set up to, I think, 1,000 different filters on your real-time stream, and you can collect up to 500,000 tweets per month before, for free, basically. So particularly in the area of floods, and say you're researching hurricanes, depending on what your filters are and how specific they are, you may not even come close to 500,000 tweets in a month. Or if your filters are more general, then yeah, just be warned. There's again, thousands of tweets coming out every second. So be careful when you're crafting your rules. There's a little bit of a learning curve. And we actually have other endpoints. We have search endpoints where you just send in a query and you get back a page of results, kind of like how the Google search works. And that way you have a real fine control over how many tweets you're pulling in. You can just paginate through it, 100 results at a time. So that's another option as well. And on my screen here, you can see some of these different links to go to get started.
Great, thank you. So another thing with the streaming endpoints, it seems like it's very it's sort of like you mentioned, it's difficult to manage when there's when the searches are very general. So what would be your recommendation for tools that you should know when you're trying to, say, collect just basically creating a data set from the stream? I also imagine that like historical data would not be coming through. It would just be from the point of time that you created that
exactly.
that lookup. Yeah,
exactly. So yeah, streaming can be kind of difficult. You create the streaming connection. It's an HTTP live, streaming protocol. But these connections get severed. So there's the challenge of detecting when the connection gets dropped, because maybe after a few hours or even a few days, that connection will get dropped somewhere, and you need to detect that on the client side and be like, oh, I lost my connection. I have to immediately reconnect, because to your point, you're only collecting real-time tweets. So if your stream is down, you're not collecting anything. We do have some features built in. We send what's called a heartbeat every, I want to say it's every 15 seconds. So you can set up a read data timeout on your end and be like, oh, I haven't heard anything for 30 seconds. That tells me I'm disconnected, because we send that heartbeat even if there's tweets to match or not. But I would also say, as a higher recommendation, is really consider our search endpoints. Our search endpoints are classic RESTful endpoints. You send in a query, we send you back a page of results. You can paginate further if you want to get more and more results. But RESTful endpoints are much easier to learn and to manage compared to a real-time stream. And with search, you can kind of mimic a real-time stream. You can ask a query every couple seconds, like, is there new data that matches my tweet? Okay, there's not. Is there new data that matches my tweet? Okay, I got 4 tweets. So you can really almost mimic a real-time stream. I call it a near real-time. There might be, a minute of latency, but in most applications, that's fine. So it's another thing to consider, is using our search endpoints. And another tip too, there's some great third-party libraries out there in Python and Ruby and others. If you search for third-party, API clients, often you can find something already written that you just download. If it's Python, maybe there's a package you install. Typically, they come with great, documentation. There's many out there that support streaming, so they've abstracted away all of the challenges there. Another alternative, if you go to our Twitter Dev GitHub repository, we have, for all of our endpoints, we have sample code. So they're very simple examples. They show you how to initiate a stream. There's looping where you can see where it's servicing the stream and echoing out what's arriving. So that's another way to really start at a very fundamental level and learn as you go.
Great, thank you.
If there are any other questions, please raise your hand and we will unmute you. And meanwhile, Jim, if you don't mind unsharing your screen and sharing so that I can start
Sure.
sharing my screen, then that would be great.
All right. You got it.
Awesome. Okay, so typically we have a networking session, but because today we are running out of time, we will not be having a networking session. At this time, I would like to recognize Naheen and Jim, who shared their valuable time and expertise with us. You've made this event a very special one, and your work is having a major social impact in many areas, and that is very commendable. Thank you.
Thank you.
For our closing remarks, we hope to see you at our future events and encourage you to stay with us, join our communities, and follow us on social media. We are on Bevy Labs, on Meetups, and LinkedIn. We will be sending out a feedback form, so please do fill that out. And once again, I'd like to apologize for what happened at the start of this program. We want to create a safe environment for everyone, but clearly there was a breach. But for future events, we will definitely ensure that only the people who are invited are actually attending our event. So thank you so much for coming, and thank you so much for attending, and we hope to see you again in the future.
Thanks, everybody.
Thank you.
Thank you. Thank you so
Bye.
much.
Have a good day. Have a
Bye-bye.
good evening. Bye-bye.
Good evening. Bye-bye.
Yeah.
Man, Steve, what happened? Whoa, that was something. That was something.
Yeah, I've
So
never
I'm
actually experienced that. It was so weird.
so weird. I'm so glad you got
but
things
I've,
under control.
yeah, but I've heard of stuff like this happening, but I've never like seen it in person. It was interesting. But
No,
it was like so much work trying to like pick
I
these
got.
people out. Like I changed it, so I created the waiting room.
Yeah,
Yeah, and then for next time, so if you click on more,
yeah,
you know, the bottom of the screen that says more,
yeah.
it says start focus mode.
Okay,
Yeah, so basically what happens is that the participants will only be able to see the host's video. So we have, so two of us are the hosts, and
yeah.
maybe whoever's presenting can be the host as well, and the
Okay.
shared content, but they can't see any of the other participants.
Okay, okay, okay. No, that's
So we can do these two things. We can create this focus mode, and we create a waiting room, and then we'll be able to manage it
oh,
better.
okay, okay. No, I think so. I think so. Because honestly, I've been sitting here, I've been thinking about, okay, because I DM a lot of my LinkedIn network, and I know, like,
Yeah.
okay, like who's coming, and but there were some names that I did not recognize. But these guys, like, they were so persistent. They kept on
I
coming.
know they
They
kept
kept on
on coming
coming.
back. I was so surprised at a
Like,
different name every single time. I was like, what the heck is this? And it was like hard to like listen to the
yeah,
the
I got
presentation and
distracted.
also like look up these people.
No, no.
It's kind of easy to tell from their names itself.
Yeah,
It looks
yeah,
like not right,
yeah.
but you know, one or two of them might have been actual people. Who knows? Might
Yes.
have been
Yeah.
like people who are actually interested. People are still trying.
They're still trying. Oh my God, Joshua. So weird. So weird. Oh my goodness. No, no, no. Like I am, yeah, I'm shocked. I'm stunned. Yeah, yeah, I agree. The two steps you mentioned, the two approaches you mentioned, we'll adopt those. We'll adopt those, and we'll
Yeah.
make sure that, because I was so distracted, I did not catch anything.
But I mean, I managed to able to get a little bit here and there. It was really interesting. I'll
Yeah,
definitely
no, they're very
look
interesting.
them up. Look
Yeah,
them up. Yeah.
I looked them up too, and it's I was able to catch some stuff, but still I had the yeah, but it was still very interesting, and I it kind of sucks that we did not get a chance to have like one-on-one conversations with them, because today we did have the option of meeting them. Yeah, we had the option of going and meeting them in breakout rooms. But it's okay. It's okay, because I did see a couple of my friends logging in like 10 minutes into the presentation, 15 minutes into the presentation, but I was like, okay, you know what? It's okay. We don't have to let them in. Like, it's okay. It's okay. Like,
Wow.
but no, but impressive guest. Impressive guest. Like,
Yeah, really good guest for sure.
yeah.
Okay. I think we can do our next event in person and virtual.
Okay.
If you want to do
Okay.
that, we can do it in my office.
Yeah.
If you want
Yeah.
to do that, we can do like maybe like 10 people in person and then the rest virtual.
Yes, we can do that for sure. For sure. I think if we can do that, we definitely won't have to worry about this. But let's meet. Let's meet in person.
Yeah.
I think we said October 19th is our next. Sorry, November 19th is when our next event is. November 19th or
Okay.
November 21st. I can't remember. It's either the 19th or 21st.
Okay. Sounds good.
But yeah, let's stay in touch. Maybe I think we should meet on Thursday. What do you think, Steen? Can we meet on Thursday?
Yeah, the Thursday is fine with me. I don't have too many meetings.
Okay.
Yeah, Thursday is fine.
Okay. No, that sounds really good. That sounds really good. No, thank you so much for your help today and the whole week. And
yeah, thanks for all your help. You're doing most of
no,
the heavy lifting.
no, it's all good. But I will send out the feedback form, and yeah, I'll send out an email to both Jim and Machine tomorrow morning.
Yeah, perfect. Awesome.
Yeah. Thank you. Bye.
Okay. Have a good night.
Good night.